welcome to today's YouTube class. Today we'll be looking at another aspect in mathematics, which is also under trigonometry. Like we have done in the previous class, we have talked about to prove some trigonometric ratios. Now we'll be looking at compound angles in trigonometry. Compound angles. And then we'll be solving some things under the compound angles. We have something called cos A plus B. So from cos A plus B we can get cos A cos B plus sine A sine B. This is how we work with compound angles with cos A plus cos B. But we should note that when our cos A is being added with B here, this place will not be plus, this place will be minus. But when it is minus here, this place will be plus. So you can see it that when it is cos A plus B, it will be equal to the inverse of the sign, which is minus. When it is cos A minus B, to be equal to the inverse of the sign, which is a plus. And so we have actually done that. Just to see that sine A plus B will be equals to sine A, and then sine A cos B plus sine B cos A. Now this one does not affect any sign. When it is plus here, it remains plus. When it is minus here, this place remains minus. And the last one, tan A plus B will be equal. We should know that tan is what? Sine A plus B, whether minus or plus. And then this one will be cos A plus B, whether minus or plus. So we want to solve using this. But I already know what my sine A plus B, this is what my sine A plus B is, and this is what my cos A plus. So let me just impute it by writing sine A plus B is what? Sine A cos B plus sine B cos A. If I should take this as plus, it will be cos A cos B minus sine A sine B. So the next for me to do is to divide both numerator and denominator by cos A cos B. When I do that, then I can have my sine A cos B all over my cos A cos B plus my sine B cos A all over my cos A cos B. I've done the numerator side. Now for the denominator side, I have my cos A cos B minus divided by cos A cos B sine A sine B all over my cos A cos B. The reason I'm doing this so I can be able to cancel out the cos A and cos B. Cancel this. And which other place do I have? Cos A cos B. I have my cos B here, I have cos B, I cancel this. So I have cos A here, I have cos A here, I cancel this. And so I guess that should be the whole I can cancel for now. Yes. So now I'm left with sine A plus sine B over cos B. Sine A cos A, yes. So I still have a cos A here. Now to give me all over, this one's I cancel those 1 minus sine A sine B sine A sine B cos A cos B. So now from here, sine A sine cos A is what? Tan A, plus sine B cos B is what? Tan B, all over 1 minus sine A sine B will be, okay, let me just take it like this. Sine A over cos A, yes, sine A over cos A will be tan A. Sine B over cos B will be tan B. And so this is how we prove for our tan. Now note that for tan A tan B, if it is tan A plus tan B, this upper one will be a plus. You get, this one here will be a minus. This one here will be a minus. But if this is a minus, this one here will be a minus, this one here will be a plus. So that's how we run that. So with that, we have been able to prove how to go about compound angles. So we'll solve some simple examples under compound angle. Example 1, to solve for sine 105, leaving my answer in solid form. So we don't know sine 105, we'll just have to simplify it in a simpler, so we can use special angles. So I know that sine 105 should give me sine 60 plus 45 degree. Yes, so if I should have this, and since there's a plus here, remember that sine A plus B, this is the result of sine A plus B. So I can just take it back to, no need for me to be writing sine A. This, remember that this is looking like a sine A plus B, so I can just write this, but I might not need to be repeating to write that. So I can just say, since I know what that is, what's my sine A, I can just simply write this is equals to sine A plus B, and the result of my sine A plus B, this is the result of my sine A plus B. So my sine A will be 60 here, so I have my sine 60 degree cos 45 degree plus sine 45 degree cos 60 degree. So I have change it just like the same way we have it here also. So my sine 60 in short form is root 3 over 2 times cos 45 is 1 over root 2. So if I should rationalize that, by having root 2 over 2 plus sine 45 is still the same as 1 over root 2. If I should rationalize that, by having root 2 over 2 times cos 60 is half. So at least by now you should have been able to know how to solve this. So this times this will give me root 6 over 4 plus root 2 over 4. So my answer should be root 6 plus root 2 over 4. You can't add root together, so that is the way you can solve that. Moving on to the next one, the next example that we have here. Example 2, I have cos 255 degree in third form. So for me to get, I'll have to solve this by making it into an acute angle. So for me to solve with an acute angle, I'll just simply do 255 degree minus 180 degree, which will give me 75 degree. So I'm having cos 255 degree. In acute angles, the value of cos 255 degree should give me negative cos 75 degree. because the answer of course 255 degrees, if you press it in the calculator, will be having a negative answer. So for us to be sure that the answer is correct, we have to have also 75 in negative form. So we'll be having this as minus cos 75 should be 45 degree plus 30 degree. Now meaning that my minus cos, okay, remember that cos a plus b is cos a cos b. If it's plus, then to be minus sine a sine b. So this I should be having a cos 45 will now be cos 45, and then degree cos 30 degree. Since it's a plus here, it will be a minus here, minus sine 45 degree cos 30 degree. So to get this, I have don't forget that your cos 45 is 1 over root 2, and if you rationalize, I have root 2 over 2 times cos 30 is root 3 over 2 minus root 2 over 2 times 1 over 2. So if you do all your abacadabra, you have this root 6 over 4 minus root 2 over 4, and that gives me okay, I can have my answer this way. I can have my answer as because of this negative sign, so I can have my answer like minus root 6 plus root 2 over 4. So this should be where my answer is. And there's even one that looks more complex. So number 3, if I have sine a equals to 3 over 5 and cos b equals to 5 over 13, find cot a minus b. Now by looking at this, the easy way to do this, anytime you say something like this, the first thing that should come to your mind is to draw a right angled triangle. So once you draw a right angled triangle, you know how to go about every other thing. Will be very easy for you to do. So I have my a here, so my angle a, and then let me assume I'm looking for this side, and then because sine, I want to work with sine first. So because sine says opposite over hypotenuse, so if a is facing this side, this is the opposite of a, so this is 3, and this is the longer side, which is 5. So I've gotten that sign. So let me use Pythagoras theorem to get my x. Pythagoras theorem will tell me that my x squared will be equals to 5 squared minus 3 squared, which is 25. Okay, x squared here, which is 25 minus 9, which is 16 x squared, and my x is equals to 4. So I've gotten this place as 4. Now to get for the cos b side, for the cos b, we're still going to do the same thing. For the cos b, I have my angle b here. So let me imagine I'm facing this place. This place is my what? Opposite. I know that for cos we are going to if I say this is my opposite here, this will be my adjacent, and this will be my hypotenuse. So cos is car, so capital AH. Adjacent will be here 5, and this is my opposite here, y. This is what I will look for, and this is my hypotenuse 13. So to solve this side, I will still use Pythagoras theorem. I will still have to do my y squared equals to 13 squared minus 5 squared, which is 169 minus 25, which is 144. So y squared cancel both sides, y is equals to 12. So I've gotten my y as 12. Now that way I can now solve easily, because they say we should find cot. So cot a minus b will be equals to Cot A minus B simply means the inverse of tan A minus B. So you can either say cot A minus B is equals to tan A minus B, or you say cos A minus B over sine A minus B, or you simply say sine A minus. So this can also mean cot A minus B, what I've written here also. So I'll prefer to do so. We can also find what tan A is from here. Tan A will be equals to tan simply means opposite over adjacent, opposite. So from here, tan A here, opposite, what is the opposite? 3, and then the adjacent is 4, and then my tan B, the opposite here is y, which is 12, and my adjacent is 5. So to solve this, cot A minus B will be equals to 1 over what's tan A? Tan A minus tan B over 1 plus tan A tan B. So if I should like the way we know it in mathematics, if I should bring this one up, if I should do the inverse of it, this one will come up, this one will come down. So that will be 1 plus tan A tan B over tan A minus tan B. You know how I did that because of this one, so I just interchanged it. So from here I can now begin to impute everything inside. So my cot A minus B will be equals to 1 plus what's tan A? 3 over 4, tan B 12 over 5, all over tan A 3 over 4 minus 12 over 5. So I can cancel this, 1 cancel this, 3. Okay, so I have 1 plus 3 times 3. And we should not forget that this one is a different number over 5, and it's all over 3 over 4 minus 12 over 5. So 1 plus, that should give me something like 1 plus 9 over 5. Okay, I can put 1 here too. Divided by 3 over 4 minus 12 over 5, which would now give me this. The LCM fraction for this one and LCM for this one should be 5 plus 9 over 5 divided by, if I should do the LCM for this fraction and everything, I'll be having minus 33 over LCM is 5, okay, it's 20, yes. So when I can interchange it and bring this, will be 14 over 5 times 20 over minus 33. Cancel here 4, and that is 56 over 33. Let's not forget the minus. And so this I've got our answer. So also we can look at another example. Example 4. If tan A is equals to half and tan B is equals to 1 over 3, then show that A plus B is equals to 45 degree. So I know that my tan A plus B will be equals to tan A plus tan B all over 1 minus tan A tan B. So what's my tan A? 1 over 2. And what's my tan B? 1 over 3. 1 minus 1 over 2 times 1 over 3. If you do the LCM of this, if you do the LCM of that fraction, you should have something like 5 over 6. And for this one here, 1 minus 1 over 6, so 5 over 6. So if you do this one, you should be having 5. If I'm not wrong, you should be having something like 5 over 6 also. Yes, 5 over 6. If I do the same of this one, I should be 5 over 6. So I'm having 5 over 6 divided by 5 over 6, which will give me 5 over 6 times 6 over 5. Cancel this, cancel this, cancel this, cancel this. So everything is equals to 1. But note that 1 is equals to 45 degree. Yes, 1 is equals to 45 degree, which is in tan. 1 is equals to 45 degree, which is in tan. So tan A plus B is equals to 1. But tan 45 degree is equals to 1. So that means tan A plus B is equals to tan 45 degree, meaning that if I cancel this, I'm saying A plus B is equals to 45 degree. And so that is how we get that one rightfully done. I don't know if I can stay, if I have time to do another example. Okay, we can call it a day from here, and then in the next class we can try again, do more examples. Thank you for joining to today's class. God bless you, but please try to subscribe and don't forget to refer people to our YouTube channel. God bless you as you do so.